All right, so let's get right into things. So today we're going to talk about fats and the endocannabinoid system. This is a presentation by Chip Paul, who is myself, and I'm doing this really on behalf of New Pharma, which is our research and development company that's dedicated to researching the endocannabinoid system and innovating on the research that we develop. We innovate through a brand called True Medics. So if you want to look at products that are coming out of this innovation, you would go to truemedics.com and look at the products available there. So again, all those products have been developed with the science and kind of thought that you'll see here in this presentation. And they all work really, really well. All right, so let's get into it. So if you've never, if you don't know anything about New Pharma or the endocannabinoid system, I would encourage you to go check out this YouTube video. But it's really a description of our model here at New Pharma of human function under the endocannabinoid system. And again, we theorize and postulate that we're kind of driving a hoopty right now because we really don't know the proper resources to put in our body. But as we understand this better and better, our function as humans will greatly improve and our vehicles should certainly be more drivable, let's say. Okay, so again, we're going to do a little bit of groundwork. So we're just going to go through the 1, 2, 3s on the endocannabinoid system. This is kind of the core of my teaching, if you will. I want you to have this basis of understanding of the endocannabinoid system before we kind of pile on top of it, right? So first question is, how do our bodies regulate? How do we regulate our, physical processes? Well, we got taught, all of us got taught, or I got taught at least in high school, that we do this through hormones. Yeah, that's kind of old thinking. There's some big problems with that, mainly like, how does our immune system work with hormones? Certainly, histamine and things like that are involved, but, there's a big holes in saying that we regulate our body through hormonal processes. We regulate our organs and some finer processes through hormones, but the hormones are controlled and managed by a higher system. So let's talk about what that higher system is. It's something called the endocannabinoid system. And again, we use 3 points on the endocannabinoid system as kind of the basis for all of our understanding and teaching on this system, because we think these are 3 very important points, and they really drill home the importance of the endocannabinoid. So point 1 is it's really old, really ancient. We developed it before we had a spine. So, again, if you're an evolutionist, that's a long time ago. And interestingly, in this guy called a sea squirt who didn't have a spine, his larva stage did have a little bit of a spine and could swim. So the guy where we developed an endocannabinoid system is also the guy where we first moved. So we went from kind of an invertebrate to a vertebrate in this same species and developed an endocannabinoid system along the way. We also developed something else in this guy, or we had it in this guy, and that's a fat system, believe it or not. So everything that I'm going to tell you today would be null and void if this little guy did not have the fat systems that I'm going to describe to you. So that's pretty cool. But anyway, from this guy, a sea squirt, pretty much everything on the planet went one way and insects went another. And insects don't have an endocannabinoid system. They have different processes of how they regulate their body. But pretty much for the most part, everything else on the planet has an endocannabinoid system. So all mammals have an endocannabinoid, fish, birds, reptiles, pretty much all flora and fauna, well, flora, fauna, I guess, pretty much all fauna around us have an endocannabinoid system. So there you go. So point 1 about it, really old, really ancient, and looking to be our, sorry, those are all 3 points. Point 1 about it is it's really old and really ancient. Sorry, I'm getting ahead of myself. I can't wait to get to the fat part. Okay, all right. So point 2 about this is it's looking to be our master regulatory system. You can satisfy yourself to the amount of research out there. NIH.gov is your best friend. That's our nation's clearinghouse for research. Use the keyword endocannabinoid and whatever, doesn't really matter. You're going to return research studies, endocannabinoid in fats, a whole bunch, endocannabinoid in immune, endocannabinoid in feeding and craving, endocannabinoid in cognitive, endocannabinoid in toe fungus. You're probably going to return a study. That's how well studied the endocannabinoid system is. It's extremely well studied. As you read those studies, what becomes apparent is down any particular silo, and the research is always siloed, right? So immune guys write about immune stuff. So if you go down the immune silo, for the most part, immune guys will agree that the endocannabinoid regulates that silo. We're kind of the first company to come along in 2015 or so and say, gosh, it looks like it regulates everything about us. It could be our master regulatory system. And the science is kind of heading our way now on that point. So again, this is looking to be our master regulatory system. There isn't the preeminent study there yet, and there's some nuances there that we'll talk about when we get into fats, which is kind of cool. But again, it's looking to be our master regulatory system. So what does this mean practically? Well, it means we work kind of like our car. So we have a hypothalamus hippocampus, and it's like the computer in our vehicle. And very similar to our vehicle, it's looking at every single system in our body. It's looking at our immune system, feeding and craving, cognitive systems, and it's managing all of these systems. If they need resources, it's providing resources to this system. You know, if it's having to manage resources on the back end, maybe it's having to compete with other systems. But the endocannabinoid system is how we control and manage all of these major systems and minor systems, sometimes indirectly, in our body. Very similar to how our car works, it's always looking at gas and tire pressure and all of these things to try to balance that vehicle to perfect homeostasis or perfect balance. It's exactly what our endocannabinoid system is doing inside of us, using our hypothalamus hippocampus. Again, so you can satisfy yourself that that is certainly the case, but point two about the endocannabinoid system is it's looking to be our master regulatory system. So point three, and this is the best news, and this is the coolest thing, because again, when we get into this conversation about fats, fats are a resource for this system. But it sounds crazy, but we can use fats to manipulate this system and potentially manipulate human function. Yeah, isn't that crazy? We'll talk about that a little bit more because it's not crazy. It's really true. But anyway, point three about the endocannabinoid system is it's driven and fed by natural resources. So again, this is kind of logical if you think about it. It's for some reason it's not obvious to us, but it's logical if you really think about it. So we need all these resources to run our body, right? Where do they come from? We need resources to run our immune system. We need resources to run our cognitive. We need resources to run energy, and we need resources to run our regulatory, like our endocannabinoid. I'm going to talk to you about, just to illustrate the point, two sort of sub resources. So dopamine and serotonin, we all know a lot about, so it's a good, easy example. But dopamine and serotonin are kind of central nervous system things. They sit below the endocannabinoid system, but it's easy to use them to illustrate a point. So again, dopamine and serotonin, we know this, without dopamine and serotonin, we are a depressed Parkinson's patient, right? So we can't generate mood, we can't generate cognition, we have brain fog, we're depressed, we're just boop, we're kind of shut down cognitively. Well, I don't want that to happen to me. I know you guys don't want that to happen to you. So give me some more, give me some more. Where do dopamine and serotonin come from? It's not like we're born with a giant bucket of dopamine and we're born with a giant bucket of serotonin, right? Our bodies have to make these things, and they do make these things from things that we eat, in particular, two amino acids called L-tryptophan and L-tyrosine, which isn't really that important. The important thing is this. Let's say I put you in a box and I said, no L-tryptophan and no L-tyrosine for you. So sorry. And then I scared you a few times for fight or flight to get all the dopamine and serotonin out of you. You would become a depressed Parkinson's patient. You would stay that way until I gave you L-tryptophan and L-tyrosine biscuit. When you ate that L-tryptophan and L-tyrosine biscuit, boop, you come right back online. So I want you to really think about that. We, as a society, we have depression and anxiety and all these mental issues. How much of that is regulatory and how much of that is permanent? I would argue very heavily that most of that is regulatory. Again, it's just a resource denial that we don't understand. We just don't understand our diet well enough to understand how these things really break down and affect our function. But anyway, point three about the endocannabinoid system is it's driven and fed by natural resources. Again, another example of this is just musculature. So musculature, I can't say that real fast. I stutter. I can't help it. If I get going, just kick me hard. I'll spit it out. Anyway, musculature. There, I said it right. So when my brain says, move your arm, Chip, move your arm, how does that work? Well, I have hypothalamus, hippocampus, endocannabinoid, its central nervous system. Central nervous system sends a signal to something called a voltage-gated sodium channel. That voltage-gated sodium channel takes that thought and converts it into physical movement. That takes resources. Without sodium and potassium, I can't work those gateways, right? If any of you were my age and were in high school athletics, you ate a lot of salt and potassium pills. The reason for that is so you wouldn't seize or have cramps, right? Voltage-gated sodium channels, providing resources through your diet. Okay, so that's another example. But again, there's example after example after example. But we don't think this way right now, and we need to, because it's killing us to not think this way. Okay, so we're going to talk, we really, my whole model, if you will, in New Pharma, the new Pharma model of human function, really has its genesis with something called the endocannabinoid deficiency model that was penned by a guy named Dr. Ethan Russo. So some of you guys have heard of Dr. Russo, but Russo was head of GW Pharma when they did all the Sativex and Epidiolex work in the UK and the EU. So anyway, he's a good guy. I talked to him a few times on the phone. He's limited, he's siloed, which is kind of sad. He's kind of, stuck in cannabis, and some of us can flit about in other places. But anyway, his model says that basically we don't understand this whole diet and everything, and we're not providing this endocannabinoid system with the proper resources. And by virtue of that, we're becoming dysregulated. So that's a great model. We've greatly extended and enhanced that model, as has he, and he's recently written about it in 2016. But that's a good model, and I would encourage all of you all to study that model, because it's looking to be right, absolutely looking to be right. Everything that we find here in New Pharma supports Russo's model of endocannabinoid deficiency and its relation to most human disease states. Okay, so again, if you want more detail on this, the 1, 2, 3s, go back and just watch the video on human function, but we'll kind of get right into the meat of it, the fats right now. And again, I'll do my best to walk you guys through this, but there'll be more and more videos on this. This is clearly a big field of study. If any of you young, bright minds want to do something, again, pay attention, because this is huge. And I'll try to drop some of the things that I know that are going on in research with some of these things, where they're working with fats, but they don't really even know that they're hitting the endocannabinoid system, or how these the unintended, I would say, consequences of what they're doing. Okay, so let's get into this. Let's just use some logic, all right? So does everybody need the same kind of vehicle? If you live in Alaska, do you need the same vehicle that I need if I live in Africa? I don't think so, right? And very similar, if we go back to the car analogy, we have vehicles for different purposes, and humans are we physiologically kind of fit different molds. Some of us are skinny and fast, and some of us are big and strong. It depends on our physiological makeup, really, what we need to fuel our vehicle. And I mean this more in the context of fats, okay? So again, do we all have the same vehicle? No. Do we all have the same engine? No. Do we all have the same needs? No. We don't, right? But they're within a certain range, okay? So, and we have the ability, it's looking like, that we have the ability to adjust within a certain range. Regrettably, we're way out of bounds right now with our diet. But if our diet were more wild, if you will, like didn't have processed food, we had to go out and hunt and gather, again, we would be within a range, a very specific range. And in that range, we could maintain health in that range, where we can't right now in our current diet. So, and that's frankly the point of all this is, how do we improve our health through our diet? So it's looking like we really can. I asked this question when you run your vehicle on sugar because, maybe you might have to at some time. Maybe you're out of gas. And what happens if you, and this is an autism question, okay? Because it will get to autism and kind of where it's disrupted in some of this. But again, autistic people have to run a little differently than you and I do because they're kind of disrupted in some major things. So again, if you're running your vehicle on sugar, you're going to have some unintended consequences of that. You're going to gum up your works a little bit more than perhaps if you were running your vehicle on gasoline. So maybe that's a poor analogy, but we just don't all quite operate the same, but we should operate pretty close to the same. All right. So how do our bodies store energy? How do our bodies store resources? There comes the stuttering. Resources for chemical mediators. So when we need to provide energy, when and where, how do we do that? How do we provide insulation for our bodies? Well, we do this through fats, right? So we do this through the fats that we eat. So what is fat? Fat is several things, right? So if you look at a fat cell, if you look at fat, that fat's going to be characterized in a bunch of different ways, but let's kind of break this down. So again, what is a fat cell? Were there really 5 different kinds of fat cells? They range in size, and you can kind of see them here. And again, some of these words I've never said out loud. I've read them a lot of times, but chylomicrons, again, they are the largest size. They have a bunch of triglycerides in them. As you move kind of up or down, I would say, in size, the triglycerides lessen and the cholesterol goes up. So again, these are how you move and manage fat in your body. So you might be storing triglycerides in one of these forms. You might be moving triglycerides around in one of these forms. And again, we're always doing this. This is always happening. It's happening right now to every single one of us. We're taking these chylomicrons and moving them through our liver and then through all of our processes. We're taking fats off of them, we're modifying them. And as we modify them, they become VLDL, so very low density lipoproteins. They become intermediate, they become low density lipoproteins, LDL cholesterol, which you've heard about, or they become HDL cholesterol, which you've heard about. So we'll talk about each of these a little bit. But not too much. I just want you guys to be aware of that you have these different types of fat cells, but they're basically characterized by how much cholesterol and how much triglyceride they have in them. So you can kind of see you go from these big cells on the left that have a lot of triglycerides to smaller cells on the right that have very few triglycerides but higher cholesterol. Okay, so that's a fat cell. Let's talk a little bit about LDL and HDL. So again, this is how you move cholesterol around in your body. Cholesterol is a kind of a broken down fat, if you will, and some other things. But cholesterol is obviously necessary for vitamin D production. It's a very important resource for our bodies. It's part of what makes up our brain. Cholesterol is just extremely important. But how do we move it around? So for the most part, other than your liver processes, which mainly deal with these smaller molecule or bigger molecules, sorry, these are what we move around in our blood. So LDL and HDL, and this is what's generally measured for cholesterol. LDL is transporting, right? So you can see here that LDL moves cholesterol through the body. Okay, so it's a transport mechanism. So when your cells are crying for cholesterol, LDL is bringing it to them. When your cells are crying for fat cells or resources, LDL is what's bringing it to them. When that process is done, you have basically some cholesterol and other things, but you want to pull that cholesterol out. And the way that cholesterol is pulled out is through HDL. So HDL basically removes sort of used cholesterol from your system, and LDL is how you deliver all cholesterol and triglycerides to your system. And we think of this in terms of cholesterol, but you have to remember you're also delivering triglycerides, and triglycerides are what we're really going to dive into here. So again, where are the triglycerides? They're mainly in these bigger molecules, and I don't know why they call them lower density, but they're actually big molecules, but lower density lipoproteins and very low density lipoproteins. So you can see that these guys have a lot of triglycerides in them, especially our very low density lipoprotein. Okay, so triglyceride. What is a triglyceride? And again, this is when we're really going to get into fats, all right? So triglycerides are how our bodies really store, manage, and transport fatty acids, okay? So we need fatty acids to perform certain tasks in our bodies, which we'll talk about in a little bit more detail in a second. But we store these fatty acids on triglycerides. Again, a triglyceride is going to be a glycosol background, and it's going to have 3 fatty acids attached to it, and it's going to look like kind of what you're seeing there on the graph. Those fatty acids can be different kinds of fatty acids, and we're going to talk about these in a little bit more detail. They could be saturated fatty acids. They could be monounsaturated fatty acids, like oleic acid, which is in olive oil, or they could be polyunsaturated fatty acids. And these are the omega-3 and omega-6 fatty acids, linoleic and alpha linolenic acids, okay? So all of these are very important in our body, and we need to store them and manage them in some form, and that's done with triglycerides. Again, there's a difference between saturated and unsaturated fat, but you need both. You need both, interestingly. And again, we'll talk about that in a little more detail too. So saturated fat, what is it? It's palmitic and stearic acids. Again, what portion of your body they make up? This is highly variable. I'm sort of giving you a range here, but we'll talk about this in a little bit more detail in a second. But they make up, roughly 20 to 30% of our stored fatty acids. And they help with palimentation. Again, some of these words I've never said out loud. So PEA, I've never said out loud, and it's coming up next. So again, if I mispronounce these, PhDs and all you guys out there, forgive me, but please go with the information and data rather than the pronunciation. But saturated fat is also our precursor for something called palmitoethanolamide acid, which I call PEA, but PEA is an endocannabinoid. PEA is absolutely an endocannabinoid. So again, you're building one endocannabinoid from saturated fat. From monosaturated fat, these are things like oleic acid. So olive oil has a lot of oleic acid in it. It is the most abundant type of fatty acid. It's found in vegetable oils like olive oil, pecan, canola, and sunflowers. So again, a lot of what we eat, fried food wise and things like that are unsaturated fatty acids. I have monosaturated. That should be unsaturated, by the way. Sorry, just noticed that little detail. But anyway, monounsaturated fatty acids are the precursors for something called oleomide. I can say that one, and it's designated OEA, but oleomide is an endocannabinoid, okay? So it's another endocannabinoid that's produced from these monounsaturated fats. So you have one endocannabinoid produced from saturated, you have one type of endocannabinoid produced from monounsaturated, and you have several that are produced from polyunsaturated fat. So polyunsaturated fat is linoleic and alpha linolenic. By the way, these are spelled different. It took me a while to realize that because they look very much the same, but again, they're two very different things. So alpha linoleic and linoleic acid. So these are, linoleic is omega-6 fatty acid and alpha linoleic is omega-3 fatty acid. These are essential for human function. So our bodies can't make these. We have to take these in through our diet. So we have to take in polyunsaturated fats if we want to function. Again, what happens with these polyunsaturated fats, we'll talk about more about that in a second. But in particular, you make something called arachidonic acid, and it's derived from omega-6 fatty acids. Most of the endocannabinoids that we talk about all the time come from arachidonic acid, all right? So both 2-AG and anandamide are derived from AA. Yep, so there we go. So again, your endocannabinoid major ligands, the major things that you use to drive processes in your body and do work, are derived from polyunsaturated fat. So all of these types of fat, you derive some type of endocannabinoid from, some type of regulatory molecule, right, to control your body is the point. Okay, so what is saturated fat? It's fatty meats, butter, ghee, coconut oil, palm oil, cheese. So dairy and fatty meats. Okay, what's mono unsaturated? I don't know why it's coming up monosaturated. I'll have to fix that. Mono unsaturated fatty acids are like oleic acid. So all of seed oils mainly, and again, some seed oils are oleic acid or have oleic acid in them. Most seed oils do. A lot of seed oils though also have polyunsaturated fat. So again, you're looking at, isn't it kind of interesting? You're looking at meat and you're looking at plants and how they come together to form our diet. But polyunsaturated fat, again, you're looking for linoleic and alpha linoleic acids. Those are mainly seed type oils, and some meat sources, right? So if a cow eats well, he's going to have a lot of omega-3, omega-6 in his meat, and I will benefit from that. If a fish, most fish eat well, there's a lot of omega-3 fatty acids in the ocean, a lot of polyunsaturated fat in the ocean. So fish eat well, and so thereby their meat is a very, very good source of linoleic and alpha linoleic acid. It's hard to find alpha linoleic acid in our diet right now, which is omega-3 fatty acids, and we'll talk about that more in detail in just a second. But again, that is a lot of what's wrong with us, is our lack of omega-3s in our diet. And it shouldn't just come from fish. Again, fish are a good source of omega-3s, but so are, hemp oil is a good source of omega-3, chia seed oil. There's a bunch of good seed oils that are good sources of omega-3 fatty acids. Okay, so you can kind of see now how these fats that we're storing on these triglycerides, right, all feed into the endocannabinoid system. So we're storing this fuel that we need to be able to do work in our body, right? Isn't that cool? And we kind of store everything that we need in these triglycerides in our fat cells. Okay, so again, let's go back to logic and let's kind of look at climate, fat, and logic, another exciting topic that we'll be covering today at New Pharma. But we can use this to make some points, right? So let's look at Alaska. Let's look at the frozen tundra of the North. We know about the Eskimos. Do the Eskimos eat plants? Not really. You can't grow plants in Alaska, or lichen and things like that, right? But you can't really grow the kind of plants that we can grow here in Oklahoma, in Alaska. So what does their diet look like? Well, their diet is really heavy in saturated fat, right? So they eat a lot of meat and they eat a lot of cheese and dairy, but they also eat a ton of fish. Okay, so if you look at on the saturated fat side, if you listen to kind of what science has been saying for the last few years, saturated fat should cause us to have heart attacks, and it's the triglycerides and fat cells are sticky, so they form plaque, and that's why we get all these arterial stuff and all these bad things about saturated fat, right? Well, that's all Eskimos eat pretty much. So why aren't they dying of heart attacks every day? And why haven't they for the last however long they've been down there, 1,000 or 2,000 years? They should all be dying when they're 30 of heart disease, and they don't. Why not? Well, let's think about this a little bit. So what does all that saturated fat do? It creates a lot of inflammation, or it has the potential to create a lot of inflammation in our body. So something goes wrong, whoop, we way overinflame because we have tons of those resources. How does that how does that inflammation get mediated? Well, one way it gets mediated, anti-inflammatory wise, is by omega-3 fatty acids. Now think about where omega-3 fatty acids come from. They come from fish, right? And Eskimos eat a ton of fish. So by virtue of staying in a balanced situation, eating a lot of fatty acid, but also eating a lot of omega-3s, they're able to balance that inflammatory aspect of their diet so they're able to function. Okay, so hopefully that makes some bit of sense, because that's a way that we can balance these fats in an extreme situation and still survive, which is exactly what they've done. If you look at an optimal situation, again, you have a balance of plants and meat sources, right? Hopefully you have those meat sources also eating those same plants that are around you. A wild situation is very abundant in omega-3, omega-6 fatty acids, saturated fat, and monounsaturated fat. Again, in a wild situation, paleo diet, we fare way better than we do right now. Okay, so let's kind of look at a triglyceride in a little bit more detail. So what is a triglyceride? It's an ester derived from glycerol and 3 fatty acids. Again, so this glycerol and again, I have trouble with that word too, so bear with me. This glycerol backbone is basically, glycerol is sugar, right? So glycerol is fuel. Glycerol is what we need to run our bodies fuel-wise. So we have this glycerol sugary backbone, and we have 3 fatty acids attached to it. And that's how our bodies store fats. That's how we store fuel. That's how we store chemical mediators. And that's how we store, basically, insulate ourselves, right? So we use these things to insulate, for fuel, and for future energy and chemical mediators, which is cool. Well, how does that work? Okay. So you kind of have this glycerol, damn it, the word, the sugar backbone. You have the sugar backbone, and the sugar backbone is going to break down into fuel. And again, we'll get more specific about that in a second. And then you have fatty acids, and your fatty acids are really going to break down into more chemical mediators that you need to run your body. So again, how do you keep, and dopamine and serotonin are a separate thing, but how do you keep these chemical mediators that you need to be able to run all these functions in our body? There's hundreds and hundreds of them, right? Well, how are they stored? Well, they're stored as fatty acids, and then they're broken down by enzymes into whatever they need to be. Okay. But again, the important thing here is garbage in, garbage out. So if we're eating garbage, we're storing garbage, and we're using garbage to run our body. But we can do better. We can do better. And the point of this whole exercise, right, is to inform. So our glycerol backbone, how does this get broken down? Well, it starts getting broken down through this process, and you have kind of an end process through this of something called, again, something I've never said out loud again, pyruvate acid. Pyruvate acid is very important to how we provide energy. So pyruvate acid then fuels something that we have called the Krebs process, or citric acid cycle. This is how we produce energy. Okay. So again, we take that glycerol backbone and we break that down into something called ATP or GTP. And that's how we fuel ourselves. That's how we run. That's how we're producing energy and fuel and making ourselves go right now. So that's a very important function that we use with that backbone. Interestingly, highly interestingly, if you look at human function, this is something that we've had for a long time, which I'll talk about a little bit in a second. So evolutionarily, we've been at this for a while. We've been at this Krebs cycle for a long time. Our sea squirt had a Krebs cycle, which we'll talk about. If you look at autism and you look at what's dysregulated in autism, you can go kind of down to the endocannabinoid system, and there's obvious things that I've talked about before. They're dysregulated with autism in the endocannabinoid system. If you go again up to a really basic evolutionary functional level of how we produce energy, right? So this cycle, this Krebs cycle, is old and ancient. It's looking like in autism that this cycle is dysregulated. Okay. And the reason, again, there's outputs of this cycle that are, it's easy to measure normal levels. And so there's acids and chemical mediators that come out of this cycle that you can measure. And those are messed up in autistic people. Those are not like they would be with most of us with autistic people. So that's a big tell. And frankly, autism has helped me kind of map all of this out. Um, so again, what chemical mediators do you get from triglycerides? Well, you're storing three types of fats there that are all competing, by the way, for a slot on that triglyceride. You're storing saturated fat, you're storing mono unsaturated fat, and you're storing polyunsaturated fat. Again, all competing for slots. Only two of those are essential, okay? Polyunsaturated fatty acids, omega-3 linoleic and alpha linoleic acid, or omega-3, omega-6 fatty acids are essential fatty acids. So we have to have these to run our body. Why? Because they break down into the major endocannabinoids that regulate us, AEA, anandamide, and 2-AG, and they also break down into the major neurotransmitter that we need to pretty much run our function, our basic function, and that's GABA, okay? So again, we're building GABA, anandamide, and 2-AG from polyunsaturated fats. Without those polyunsaturated, and they're mainly omega-6s, which thank God for us, or because we have a lot of that in our diet, or we wouldn't have the chemical mediators that we need. We'd be in our L-tryptophan and L-tyrosine box. And we kind of are anyway, but it would be far, far, far worse if we didn't have omega-6 fatty acids, which we have too many of. Okay, so we have, again, essential fatty acids. The essential fatty acids are competing in our diet for a spot here on a triglyceride. If we ate 100%, if we ate very little, let's say polyunsaturated fat, let's say we ate 1%. Oh, I think I actually do this on a slide. I do this in a second. I'll go through this in a second. Okay, but let's look at what we should look like. So again, what should this look like? This makeup of saturated fat, mono unsaturated fat, and polyunsaturated fat. What should that look like for us, for humans? Again, if we knew what that should look like, that would indicate what diet we should be eating. And if we eat that diet, then we should look like that, and we will look like that, and we should get the intended benefits. All right. So again, what's a wild diet look like for primates? Well, a lot of polyunsaturated fatty acids. I mean, 54% of their diet are polyunsaturated fatty acids. Where do they get these from? Leaves of fruit trees, okay? But again, they eat a lot of polyunsaturated fatty acids, very few mono unsaturated, and some saturated fat. Most of that they get from plants, okay? So again, on the right-hand side here, you have a look at the makeup of fats and different things. If you look at beef, again, beef has a lot of saturated. By the way, that can change in beef. So we could alter that by diet. So we could move those needles and bars by diet, but we're looking at kind of averages here. So again, beef has a lot of saturated fat, not as much as coconut oil, not as much as butter. Cocoa butter has a little less. Again, you're looking potentially for things that are balanced, but you want things that also have some linoleic and alpha linoleic acid. Chia isn't on here, but it's very heavy in alpha linoleic. Hemp isn't on here, but it's very heavy in alpha linoleic. So again, you have things that do are heavier ratioed alpha linoleic. But as you eat these things, again, you're eating the ratio of fatty acids that are associated with those things, and you're putting those same ratios in your triglycerides to make you kind of what your makeup is, okay? Hopefully that's making sense to everybody. It's just kind of logical. But as you eat fats, you're eating certain ratios of saturated, monounsaturated, and polyunsaturated, and that's what's sticking to your triglycerides, all right? So again, this has been somewhat, as far as ratios of fats, have been somewhat well studied, you know, in diet. Greeks eat well, so Mediterranean diet, right, seems to be, they live, you know, longer generally than most of us. So everybody kind of looks at the med diet as a good example of a diet, and it may be the best diet that we have available right now, but it doesn't necessarily mean that that's the best diet. But what is interesting about the Mediterranean diet is, again, you have fewer saturated fats, you have more mono unsaturated fats, and you have higher polyunsaturated fats, but you have balanced polyunsaturated fats, which is important, okay? So we need to have basically a balance in our polyunsaturated fats of omega-3 and omega-6 within certain ratios. So you can kind of see here, we'll kind of get into it here. So this is from a study done by a lady named Dr. Artemis Simopoulos. Artemis is colleague, let's say, so I've talked to her a couple of times on the phone, or did. She would be almost 100 years old now, so I very much doubt that she's still alive, but she may be. If you are, hi Artemis, great work. But she did most of the work on the Mediterranean diet with omega-3 and omega-6 fatty acids. This graph is basically from one of her studies. But if you look at total fat and what we used to, in a paleo diet, you know, when we were kind of Neanderthal-like things and we were eating, you know, more wild, let's say, in the past, that was about, we had about 22% total fat. Okay, so in a paleo diet, you know, we were way leaner, I guess, and right now we're at about 36% total fat. Okay, so again, perhaps you've gone to a gym or something, and you've looked at your fat ratio. Again, currently, sadly, that's about 36% that a lot of us have. Okay, if you look at how that's made up, the past 22% or current 36%. Saturated fat in the past made up about 8% of that 22. It now makes up about 26% of that 36. Okay, so that's big. That's a lot. So what have we done? We've increased our fat, but we've increased our fat by increasing our saturated fat, which probably isn't the most healthy thing to do. On our polyunsaturated fat, again, in the past, we had about 3% of our diet was alpha linoleic acid or omega-3s. Now it's down to less than 1%. It's at about half of 1%. On polyunsaturated fat, in the past, that was about 6%. So again, you can see those ratios of omega-3, omega-6 in the past were 1 to 2, and they're now 1 to 20, or 20 to 1, 2 to 1, either way you want to look at it. But in the past, we were 6%, and currently we're at about 10% on omega-6 fatty acids. Thank God we have omega-6 fatty acids there, or we wouldn't be running our endocannabinoid system, and we might be like jelly muffins, who knows? But anyway, you need these things in balance. Okay, so let's think about this logically real quick. In our diet, only a half of 1% is an omega-3 fatty acid, okay? So we have lots of competition on this triglyceride, right? And in our current diet, we're throwing a lot more saturated fat at this guy, right? So we have a lot more just saturated fat triglycerides. When those move around in your system, they're sticky. They stick. That's plaque, okay? But saturated fat triglycerides are more sticky than polyunsaturated fat triglycerides. But again, we're eating 0.5% of our diet is omega-3 fatty acids. So let's just do the math. That's 200 divided by 3 chances of getting an omega-3 fatty acid, well, 3 over 200 really, of that probability of getting an omega-3 stuck on a triglyceride, okay? So, you know, it's not real high. It's not real high. So again, the more O3s that we can take in, the more we increase the probability of getting at least one of them stuck on a triglyceride so their bodies can use them. Now think about practically what happens here. So let's say I've got some need in my body for an omega-3 fatty acid. And again, that's going to be translated through my endocannabinoid system, hypothalamus hippocampus. Hypothalamus hippocampus is then going to go, guys, we need omega-3s, release the triglycerides. And the triglycerides will whoop, go up into our serum blood, right? Whoop, we pick them up in our serum blood. But guess what? We don't got many omega-3s. You might have to fight through a whole lot of triglycerides to get that one that you need. Endocannabinoid tells hypothalamus hippocampus, shut her down. Got the omega-3. But again, you can see the problem. You might have to pull up 6 times as many triglycerides as you normally would to find that one omega-3 fatty acid that your body needs functionally to do something. So why do we have high cholesterol? Well, gosh, if we're measuring cholesterol in the transport, LDL, and we need omega-3s and we don't have any stored, we're going to have to pull up a whole lot of LDLs to find our omega-3, right? So cholesterol, high cholesterol, may be an unintended consequence of us being deficient in omega-3 fatty acids. Hopefully that makes sense. Big point, that one, big point. Okay, let's move on. All right, so omega-3 and omega-6 fatty acids. What do these guys do? Well, it's kind of cool. They kind of work in opposition, right? So omega-3 might do one thing. Omega-6 probably does the opposite thing. Does that with cell tissue, does that with adipose tissue, almost all adipose tissue. So omega-6s will stimulate that tissue. Omega-3s will calm that tissue down. Inflammatory wise, omega-6s are inflammatory. So they are what help us inflame, right? They're help us build prostaglandins and all the things that help us inflame. Omega-3s contain these things that help us deflame and control inflammation. What else is interesting here? Oh, energy wise, again, omega-3s really cause an uptake in energy. Anybody ever heard of telomeres? Telomeres used to be what we thought was kind of our aging clock. Okay, so it used to be, you know, how do we age or why do we age? Pretty much everything in us regenerates. So why in the world will we age? Well, it used to be thought that it was telomeres because every time your cell goes through mitosis, this telomere tail kind of loses a chunk, right? So we used to think, oh, well, the telomere tails just go down and then your cells can't reproduce anymore and you die. Not the case. Again, lots of things that make telomeres go up, including omega-3 and omega-6. Well, omega-6 make them go down, omega-3s make them go up. We probably don't have a very good telomere expression right now as a population because of all the O6s that we eat. Waist circumference, omega-6s make it go up, omega-3s make it go down. Okay, so let's go back to our climate, fat, and logic slide a little bit. And again, if we looked at these different types of fats that we're putting on our triglycerides, if we're an Eskimo, we're putting a lot of saturated fat on there, but we're also putting a lot of omega-3s on there by virtue of our diet. Okay, if we're wild dieting like a gorilla or like a primate, or, you know, we're living in the wild, we're not relying on processed food. Again, we have abundance. So if we know enough about what we need to eat, we have abundance where we can eat certain meat sources and dairy for saturated, certain plant-based sources for monounsaturated, and other plant-based sources for polyunsaturated. And again, that's where we'll go with our Western diet eventually when we get this better figured out. You know, so again, we're a long way from getting this figured out. You know, what is the proper fat ratios? We don't know, right? But again, just consider this and think of this logically, right? So it's, you have an extreme situation where somehow as humans, you know, vehicles, if you will, we're able to mediate that extreme situation by virtue of our diet. What would we look like, you know, if we really understood this and could really maximize all of these things? Again, what logic says that you don't want to do is you don't want to be up there in Alaska eating a high, interestingly, and this is a kind of recent study. So since the 60s, Eskimos have started having heart attacks, more and more heart attacks. So this was pretty heavily studied, and they begin to, again, look at diet. Why was this happening? Well, guess what? They started eating more processed foods and less fish. So they cut down on the omega-3s and they up their omega-6s. Omega-6s help with inflammation, as does fatty acids, as does saturated fatty acid. So they, again, if you replace an anti-inflammatory with something that's inflammatory in this situation, that's going to kill you. You won't be able to mediate inflammation. By the way, 80% of us, 80% of us will die of some inflammatory disease right now. 80%. Okay. We got to get this figured out, friends. But it's pretty logical and simple, once you kind of begin to understand some of these concepts. Okay, so again, let's look at human function. Let's just talk about human function real quick. And let's go back to this sea squirt guy, right? So he's an invertebrate that produces in his larva stage a little vertebrate thing that moves around and moves to a different rock or whatever, right? So what does he need, really? Well, he needs a way to produce energy, right? So he has to produce energy. He produces a larvae, so he has to reproduce. So he needs some reproductive system. He's got to be able to take in nutrients to produce energy. So again, that's energy. The larva stage, he's got to be able to move, and he has to have some kind of basic immune function, right? So he's got to be able to defend himself. If he gets squished, he's got to be able to repair. If he gets some kind of virus or something, potentially he's got to be able to fight that off. Well, all of these things can be derived from fat-based mediators and energy. So meaning that he didn't need an endocannabinoid system. He developed one. Well, why? Again, he might be the beginning of when we began to move. So as we develop motility and as we develop higher functioning organs, we would need more control and regulation over those organs. And we would need a regulatory system then that's not basic and kind of very prehistoric. This fat system is very basic and prehistoric. Again, I'll go back to autism. Again, we have this Krebs cycle here described on the right. Autistic people don't do this right. They don't. One of the most prehistoric ways that we survive is messed up with autistic people. So that's a wowzer. That's got to put sugar in your vehicle, and we hope for the best kind of down the road. But certainly with that knowledge, oh my gosh, can we begin to really kind of attack that, or therapeutically, let's say, attack that disease state, which we will. Okay, so again, let's go back to this slide of the endocannabinoid system, the thing that I talk about all the time, point 3. The endocannabinoid system is driven and fed by natural resources. Well, really, what does that mean? Well, it means that we have different categories of resources. And this is really cool, I think. So we have these fat-based resources that are really responsible for our energy. So how we gain energy and how we fuel basically ourselves, take in nutrients, all of that. And they're also responsible for our immune functions in a very basic way. So in a fat-based system, we can inflame and deflame. So there's enough there to be able to run an immune response. Again, we had to be able to reproduce and a few other things there, but we were a very prehistoric, very basic thing at a sea squirt, but we had these fat-based systems. At a sea squirt, we developed something called an endocannabinoid system. It certainly is looking like this endocannabinoid system is our master regulatory system, but it's driven and fed by this higher fat-based system, okay? And as we develop higher function, as we develop more organs, as we begin to walk, as we begin to move about, we needed more and more and more regulation. Can fat mediate inflammation in an organ? I don't know, but the endocannabinoid system can. So the endocannabinoid system is a little bit finer control of how we regulate our body. So again, if we need to regulate an organ, we're going to go to even finer control. We're going to use the endocannabinoid system to hit the pituitary to do so with hormones, right? So let's talk about this last little thing, because I think this is cool. Let's talk about cognition. So The things that you need to run your regulatory in the endocannabinoid system are derived from your fat-based resources, okay? The things that you need to drive your cognition, your mind, your fight or flight resources, your fight or flight response don't come from fats. They come from bacteria. They come from bacterial processes. It used to be that it was thought that these had to come from outside of us. In fact, if you look at amino acids, this is how amino acids are produced, and you have essential and non-essential amino acids. The essential amino acids are produced through this bacterial process. This bacterial process, it used to be thought, couldn't happen in humans. The latest thinking is that this bacterial process happens in our gut, and it happens all the time. So how do we manufacture the chemical mediators that we need to run our mind, our cognition, and our fight or flight response? These look to be gut-based mediators that are built in a bacterial process. So again, when we were a sea squirt, we didn't really have a gut. We had a gut, but it didn't work that way. We had a gut, but it didn't manufacture bacteria. So we weren't as evolved. The next step in evolution, the kind of go down that evolutionary ladder, as we developed a gut, and as that gut began to develop these bacterial processes, we began to develop fight or flight responses and more cognition. I don't think anybody's ever kind of put these things together before. So this might be a new and unique evolutionary step, let's say. But anyway, all these things are very important to how we regulate our body. None of this happens if we don't understand this fat cycle that we're all in. But the coolest thing is that as we begin to understand this, medicine is your food. And that's so, I don't know why that's so hard for a lot of us to believe. Even me, I mean, I know all this. I adjust my diet and kind of, I mean, I supplement around these things, but I still like my cheeseburgers and French fries and all those things. So again, even as we know these things, it might not cause us to adjust, but we have to supplement for these deficiencies. And in order to be really, truly healthy. But again, the cool thing is, in what world, if you look at the two most major things that medical science has gotten wrong, that are getting worse, not better, in my mind, there are two of them: autism and obesity. Autism can be addressed by these thoughts and principles, and is right now. Obesity can be addressed by these thoughts and principles, and is right now. I mean, isn't obesity just inflammation? And again, we're talking about inflammation right now. Now, again, there's a balance of inflammatory and anti-inflammatory things that looks to be very important in how we balance our diet. But if we know what we're eating generally, way too much saturated fat, not enough omega-3s, it's a pretty easy thing to begin to supplement and see improved health around these ideas. All of this stuff, science, thoughts, ideas, our intellectual property, our patents, our research, our work with the University of Mississippi, all of this goes into New Pharma. Again, New Pharma uses all this tech to really build advanced formulations in a brand that we call TrueMedics. So right now, if you're looking for solutions, we have solutions within that TrueMedics brand. And if you want to know more, there's videos associated with most products, and there's lots of information out there. Now, generally, most of our products, you need some understanding of what I've just sort of walked you through, to understand why they're designed the way that they're designed, and then understand, what they're trying to accomplish, how they're trying to solve the problem, so to speak. But what you'll find is that all of our stuff works very, very well, and works as advertised. So we have a lot of activities as a company. If you want to learn more, we do teach classes on a regular basis. We do that in Owasso, Oklahoma. We'll do about once a month, we'll do a class where we're doing a bud tender or an advanced class. We will come to you. Again, that needs to be scheduled, but we do custom classes for dispensaries or CBD stores, retailers, chiropractors, yoga studios, you kind of name it. We'll come in and educate your staff. And again, if you want to sell our product, we'll come in and educate your staff around our product too. And that certainly makes it sell better. And we see that all the time. We also do custom classes for researchers and professionals. So again, if you're a research situation, or we're building some classes right now for a Colombian Colombian research medical marijuana company. So we're kind of all over the place on classes, but happy to come help you. I would guess that over time, these classes and information will go into some kind of platform that we'll be launching probably within the next year. But that'll kind of put all this together in a more cogent way than it is right now. Again, if you go to expos, we're always teaching and training at expos. We usually have an expo presence at the major expos. And please come see us at the booth, come say hi. I love to talk to people and love to hear about you and kind of your situation. And we do that all the time. If you want to know more online, we do have one class up. It is kind of the main class, but it's at themasterregulatory.system.com. That's on Teachable right now, but as mentioned, that platform will be changing over time. Teachable's okay, but it's not great. And I really want to be able to give you quizzes and ask you questions and make you do homework and all kinds of stuff, which we'll do in a better platform coming soon. Anyway, that's it. If you need to contact us, feel free. It's Chip or Cynthia Paul, and there's our address there. Sorry for the phone. Email is probably the best way so that we can schedule things, but we'd love to hear from you. And we hear from people all the time. So again, thank you guys very much. Very much enjoyed doing this with you and look forward to talking to you guys soon. If you have questions, leave them in the thread and we'll get to them. See you guys later.